Yeah, I'm Danny Kruge, or Kruger in Dutch. I'm going to speak about SQL optimization. Let me try and see. I think I have a notification. 1 second. Okay, this will be the agenda. I'll be talking about me, myself, and I. And let me close on the notification so I can see it on my screen. What is optimal? Top tips. And Azure and what I did for online dashboard, and I will explain more about those shortly. Me, myself, and I. So I'm a SQL DBA turned Azure legend. How did I get to this status? I started off as a music producer. I left college and I didn't know what I wanted to do. The plumbing courses were full, so my mum said to me, why don't you do music? This is what you enjoy. So yeah, I did 3 years of music producing, and on the side I worked at a sports store selling shoes. But yeah, I wanted more money. So I went into first line support, IT support for a retail store. And I was good at it. I ended up training the whole team while I was still new in developing. But yes, again, I wanted more money. So I went on to being a SQL DBA as a junior for the same retail store. As I did a network course while I was at the IT support level, I got myself certified as a CCNA. And they thought, okay, well, if he can learn the network side of things, why can't we teach him SQL? So SQL DBA it was. And then I wanted more money, so I came to Amsterdam and I worked for a company called Abelli, and I wasn't a junior SQL DBA anymore, I was a DBA. And it flows again, more money. I came to Schuberg. So what is optimal? I won't read them out to you, but it's not over-solving the issue. What is the time that it's okay to walk away from thinking that it's optimized? What's the customer happy with? Is it the resources are okay, CPU's down? Is it time that the query, for example, is running? Those are questions you need to think about before you just continue. You can go into a rabbit hole and just work on that for however long you want. So, top tips. Try to understand the SQL query. What are they trying to achieve? Can the query use indexes? Is the table of the SQL, is the SQL table, is it over-indexed? Is it needing indexes? Yeah. And also specify the columns. Yes, I did select star in the title, but you should specify the columns that you're selecting from. And do you need all the data? Are you needing to pull the data back, or can you select smaller amounts of data? Where I would always look is the execution plan. Check out what is actually going on behind the query, how it's being optimized by SQL, how you can improve it, and one of the big things you can look at is warnings, implicit conversions. I'm not going to go in depth because we could stand here for hours talking about these in more detail. If you do want to know more, reach out to me. We can talk about it. Talking about Azure SQL Managed Instance, I named a few topics here that I want to discuss. Index maintenance being the first. It's not as important as the second one, but a lot of conceptions would be that it's an Azure SQL Managed Instance. It's all fully managed for you. That's not true. Yes, a lot of it is, but the indexes aren't maintained. Meaning that they don't get reorganized, they don't get rebuilt. You have to do this yourself, which would be via SQL scripts or many ways to achieve it. So please be aware of that. Also, updating statistics. I see that as the most important, and I'm happy to discuss this with anyone, why I find statistics important over indexes. One of the reasons being, a lot of people think if you rebuild indexes, that's fixed the performance issue. I don't see that as being true. I see it as when you rebuild an index, you actually update the statistics, and that's what's more important. So that's why I put most important. happy to discuss further. But also, updating statistics, that is not done for you. You have to do that. Yes, there is auto update of statistics, but that's done at a fraction of the data. So you have to update a certain amount of data for that to be activated. And if you don't, you are relying on old statistics. And for Azure, the more optimal you make it, the less you pay. Bonus. Because the less resources you're using, the less money you're going to have to pay to the Azure people. There's no SQL Server agent, so how are you going to do the stuff that I'm saying? I've put a couple ways of doing it in there. Data Factory being one. You can trigger a store procedure, which is on the SQL DB. An automation account to also trigger 2 ways. There's many ways to achieve it, so I'm not going to go in depth about it. But also Ola Hallengren, a very famous guy for SQL scripts, and we use him for this Schuberg Phyllis database on-prem. And we use the scripts throughout the Acmea team, and asset management, I know, is also used. And they work on Azure, so you can actually just use those scripts which are pre-made and use them. Auto index tuning. So I spoke about that the indexes aren't maintained, but there is an option for auto creating and auto deleting indexes in Azure. The good, the bad, the ugly. Why I put that is that I don't trust it. And I'm happy to discuss this with other people as well. But I tried it. I gave SQL Server a second chance. And on-prem, when you look at the execution plan, it will give you warnings or like advice, basically. I can't think of the right word, so let's use that one. And it will give you a missing index. SQL Server doesn't look at what's actually already on the table. So you could be generating index after indexes, and you're just making the whole situation worse. Yes, your one select query might work better, but you have an insert statement that is now taking twice as long. And I tried it in Azure. It gave me a critical index I should be putting on there. It made no difference. It slowed everything down. It was not what I wanted. So please be aware that if you do this, do you really want indexes being created automatically on production? And if you have a slowdown, is that where you want to be looking, trying to find out, oh, an index was just created? Something to discuss. I'm not a fan, but that's my own personal opinion. I put in the Schuberg Phyllis database at the bottom, because on-prem, we actually have one which is auto-deployed when you create a SQL Server. I mentioned this in the SIG Azure channel, that I want to create or help create a one for Azure. If this is going to be a DAC pack, which we would deploy with managed instances, the problem is then you're paying for a separate database. So ways to incorporate this on an Azure SQL level. There's many ways to do it, and I'm not going to also mention them now, but it's in the making, something to think about. And I mentioned how I approach the online dashboard project. So recently I was interviewed by Microsoft, and that was talking about what I did for the online dashboard project. It's a report for Acmea, basically, a dashboard report in Power BI. And it was a third party was asked to do the architecture to give you some insight, and it was running for about 18 hours, the SQL queries, and who knows how long they would have gone on for. But it now takes 12 minutes to get it into Azure and 2 hours processing the report, which is faster than the 18 hours of them just trying to retrieve the data. So what did I do? I did not do what he did. I understood the issue. I wanted to know what they're trying to get, what data and how. They were using a Power BI data gateway to select the data, which we hosted on an app server on-prem. The reason I knew that the issue wasn't coming from SQL, I used a tool called SQL Query Stress. This is a simple tool, a very easy one to install. And you just fire queries at will. And I did. I used the same query, and I got the data to the app server in 5 minutes. So network and SQL was not the issue internally. Where was the issue? Power BI Data Gateway. As I watched Task Manager, I could see data coming into the app server from SQL every few seconds, and then stop, and then again, but only in 16 megabyte chunks. So the Power BI Data Gateway was not a good choice of architectural design. So we knew that this was not the way to go forward. How to go forward? Data Migration Assistant is just a simple lift and shift tool. I used that to see how fast I could get the data into Azure SQL. That took around 3 hours. That was not fast enough for me. I wanted to see what else I could do. So then Data Factory happened. And I will talk more about that now. Data Factory, it's like an orchestration tool in Azure. I actually really like it. It's quite easy to put together, and I could have a lot more flexibility in moving the data. So it gives you a rundown of what I did, and I'll go into more detail about them. Splitting the largest table, using the customer ID to dynamically partition. It's not a primary key or a unique value. The customer ID had maybe 100 rows, and all the data, was like 200 million rows, were split between those IDs. So I'll go into more detail about that in a second, but I limited the amount of rows per file. I'll also talk about that in a second. And test. Many thousands of tests I did to try and see which is the most optimal way of going forward. There's no right way, there's no solution. Every SQL query is different. Every table can be different. It's a bit of a dark art. You have to, over time, you get experience and you sort of see certain resemblances in other past situations. So you get used to what you're looking for and how to treat certain things. Let me show you what I mean. I split the table. So as you can see, there's a comment in there. Please read that one. Also, from my database, the largest table I split. So I did it by a group by. I just did a select star from top 1,000 rows of the table to try and embrace what the data was and see, okay, what are they trying to select? How can I split this data? How can I move it faster? So I just did a select count from customer ID, realized there was only around 100 rows, maybe 150 max. And then I did a group by. And that showed me the number of rows per customer ID. So that was a good stepping forward. But what could I do with that? So within Data Factory, you can dynamically partition the data. Obviously, you can do it if the table is already partitioned, but this was not. So I dynamically partitioned it. Down the bottom, you will see partition column name, customer ID, and the upper bound of 90 and lower 5. I'm going to tell you what that means now. So what that is explaining is that with the table, anything, it's going to do a where clause for you. So anything above where clause greater than 90 is going to be in one select statement. Anything lower than 5 is also going to be in one. So that's 2 splits, but you can go into further detail. And on this screen is where I show that. So I did also limit the number of rows, and I'll explain why in a second. But to dynamically partition this more, there's a degree of parallelism. You'll see the number highlighted 32. So what I do is send 32 separate queries of different where clauses to the SQL Server at the exact same time, and I break its absolute bull stuff. So I hit the server as hard as possible, and the data actually retrieves in about 12 minutes. The SQL Server is hit hard, but it's an ETL server and it's a data warehouse server, so it's possible to do so, and it has no impact on other things. It's not the solution for everyone. This works for Acmea and Online Dashboard. The reason I limited the amount of rows, you'll see also I highlighted max rows per file. What is that? 8 something, whatever it is. I split it to that number because what was happening with my where clauses, it's not perfect. So sometimes there was more data going into one file than the other. And the third party picking up the data, because this is going to a storage account, which we'll see, is going to a data lake storage. But with it going to there, some of the files were, say, 7 gig and some were 200 meg. What they do from Data Factory is also loop around the files. And if one is 7 gig, they only have one query going from that file, which is taking a long time. So if I could split it where each one was roughly 200 to 500 meg, then they can retrieve the data faster. Because to give you a quick overview, we moved the data to a data lake storage. The third party lifts it from the data lake storage to Azure SQL. Yes, you can cut out the middleman. They didn't want to do that. Different topic, different day. So finally, the end. This is the screen where you look at for the optimization side of things to get all the details about it. You'll see the SQL Server, the data lake storage on the top, and also the amount of rows which is being moved. On the left, you'll see SQL Server, 290 million rows retrieved and read. I shot 32 connections at it, and also at the data lake storage, the files written, 54. So it obviously, because I limited the rows, I even did even more SQL queries than what I actually specified in the parallelism. Trying to say that word is not easy, so I'm glad I just did that. And you'll see the total duration down the bottom right, 12 minutes, which is completely obliterated the 18 hours which it first started at, and you'll see the throughput also. So that is me, and any questions about that, and I hope it was clear, but please reach out to me if you do have any questions and want more in depth, because I wanted to go over it as an overview so you could easily understand.
No questions?
Thank you for listening.